Hello everyone, it's Zenith20 back again, and in this video I'll be explaining one of the most difficult array methods that exists in JavaScript. I'm talking about array.reduce. Now, you might have heard about array.reduce, that it's one of a kind of a method because it kind of summarizes and emulates other kinds of array functions. It's one of the difficult functions considered by many devs. So in this video, I'll be breaking it down step by step for you, and I'll be mentioning some use cases as well in which you can use array.reduce efficiently, and then it can be performance efficient. Okay, so first of all, I have a number array because array.reduce does reduction on an array. The main definition of array.reduce is that it reduces an array to a single value. So let's write an array.reduce method. So let's suppose find the sum of our number array above. So we'll declare variable sum. And in this, I will call num array, which is the array we have, dot reduce. Dot reduce takes a callback function, which we'll define here with our arrow function. So this is the callback function. Okay, now there are 4 parameters in the reduce. Our first parameter is the accumulator, which I'll explain in a minute. And we have the current value or the current number. And we have the current index, which is being accessed. And we have the array itself, which we are accessing. Those are the parameters. And if we look after our callback function and we place a comma, then we can enter another value, which is basically the initial value. Array.reduce takes an initial value before it starts its computation. So in this case, we can give the initial value to 0 or something because we basically want the sum. Now, this isn't necessary because if we will omit the initial value, the reduce function will look into our given array which we have provided to it, and it will select the first value on its loop. Now, if we return our accumulator and we console log our sum, we can see that we're getting 10, not a real big thing because there is no loop, there is no process being done over here. So what exactly is this accumulator thing over here? So first of all, you need to understand that accumulator means previous value, or it's basically a fancy way, a real fancy way of saying the total value or the total which is being calculated from our function. So reduce is like a small memory holder, and that memory is held inside the accumulator. You can add in the value in the accumulator, or you can just keep the sum of it in the accumulator after we are processing the current value. The current value and index is accessed as normal as it is, and the fourth parameter array is the array which we have just given in this case. Now we can try console logging this out to see what exactly is this loop doing. So we'll console out the accumulator and the rest of the values as well. So we can see right here that it has given us 4 loops, and I'll tell that in a minute. So first of all, we can see that it has accessed 10. The accumulator has accessed 10 as the first initial value because we haven't specified the initial value. If I was to give it, suppose 30, you'll see that it has taken 30 as the initial value. When I remove the initial value, you'll see it has taken back 10 as the initial value. But then after that, we see something funny over here, which is we're getting undefined. That's because we need to return the accumulator after every callback function. The callback function is run on each of the elements, and if there is no accumulator or total value being returned from that function, we are definitely getting undefined. So to fix that, we just return our accumulator over here. And you can see we're now getting 10 again and again and again throughout the whole loops because we are not changing the accumulator in any way. Then we have the current value, which is as straightforward as it is. We are getting all of the values 20, 30, 40, 50 as expected. And then we're also getting all of the variables, which is 1, 2, 3, 4, the indexes of the array, and we're getting the actual array as well. So we're also getting the actual number array. Now, this fourth parameter isn't really necessary, and in most of the scenarios and situations, you won't be needing this fourth case because It's not much of a use because we're just getting the same array, and until unless you have to access it under some condition, then only you can use it. Otherwise, we do not need it. That simplifies stuff a little bit. Now, the second thing before you start using the reduce method is that you need to name your parameters according to the context. In this context, we are taking the sum of our variable, sum of the array over here. So it would not make sense that if you're naming our parameter accumulator, current value, and index can remain same, but we can name our accumulator to total. The changing of the name does not matter. We can change our current value to current value, or we can name it current number. Once again, it does not matter if we change the name of the parameters, the value of the parameters remains same. You can see we're still getting the same output. Now, we want to get the sum of this array. So we have the total and we have the current number. So getting the sum of it is just as easy as adding the total and the current number. And that's really it. We can console.log the value of sum, and you can see we got 150, which is the sum of 10, 20, 30, 40, and 50. If we suppose remove this and we have 10 and 20 in the array, we get the sum of 30 accordingly. So that's basically how this array.reduce works. And if you were to write it in more simple ways, you could have just done this. For let I equals to 0, I is lesser than num array.length I plus plus. So instead of doing this reduce method over here, we could have just named another variable, sum, and we could have added new sum plus equals to num array I. And if we console log new sum over here, okay, so it is nan. Yes, so if you make new sum equals to 0, you can see that we're getting the same result. So the for loop is exactly the same as this array.reduce method. So you can now try to get an idea of how the array.reduce tries to emulate the rest of the functions. And it allows you to create really weird kind of combinations of the array methods like the array.filter or the array.map. So now that you've understood how this reduce method can be related with simple for loops, let's go for taking out an average. So this was our sum example over here. So now to create an average, let's just rename our variable to the average. And we will give an if statement, and we'll check over here if our index is equals to number array dot length -1. Make sure it's -1. Otherwise, this if condition won't work. And then else. So let's start filling with the else. So if it's not the last index element, we need to keep on adding the elements. So knowing that total is a number and current num is also a number, we're returning the total. All right. And if the index is equals to the last index, we just return total divided by number array dot length. And that's it. We get the average. We can change this value to suppose 1 and 2, and we'll get the average again accordingly, which is 0.5. We can do this between 1 and 1, and we'll get 0.5 again. 1 and 5, 0.5. Okay, not 0.5. Wait a minute. There's a bug over here. We'll have to add the total above. All right, that was the minor error. And there you go. So now if we take the sum of 10 and 20, you can see that we're getting the average of 15 accurately. So this was another bug which you need to keep an eye out for. You need to add the total first of all, and then do the if condition. So we add the total and then we check if it's the last index. If it's the last index, we return the total divided by the total length of the array. Otherwise, we keep on adding to the total, which we've done over here. Now that was the example of average done. And up until now, we have seen how the array.reduce can bring down an array to a single value. But we can also map values to it, and we can also return an array. So suppose if we wanted to map an array, we can remove all of this. We can rename our variable average over here to map. Suppose if we wanted to double every value in this array, that's even easier. We just need to add in our initial value an empty array. Make sure you do that. And then we are going to push in our total. This time again, the context changes. Our total is this array. So it would be much better if we could name this to the array. So now that makes much more sense according to the context. And we can return array.push along with the current number multiply by 2. So again, what I've done over here is another error which you should look out for. Basically, what we are doing over here is that we're returning array.push instead of the array. Again, this is a big no-no if you're trying to work with reduce. So it will be a really confusing thing to work with reduce, and you'll encounter many errors as I'm doing right now. So it's better to double and triple check in the reduce function. So we first of all push in the array, and then we return the array. And now you can see we're getting the answers. We're going to double it. And you can see we have mapped each of the values to its double values. So you can see we have returned an array over here. Now to avoid any further bugs, you should make sure that you're always passing an initial value. This is a heads out so that your array.reduce can work as normal as it can, because you'll be knowing what will be the initial value and you won't run into unexpected errors. That was the map done. So we have checked how we can do the map. Now we can also filter out the values. Suppose I wanted to filter from my number array the values which are greater than 10. That's again very easy. If our current number is greater than 10, then we return, then we wait, then we array.push. We push array.push into it the current number, and we return the array. Else, we just return the array. Make sure you're returning the accumulator or the array over here, otherwise your reduce will not work. And we can see that we've got the correct answer. 10 is not in the array, final array, which we're getting from this filter function over here. That's really nice. Okay, what if you wanted to find now duplicates from the array? So suppose if I have some more duplicates over here, like 40, 10, 30. What if you wanted an object which could contain the number of duplicates your array has? That's again very easy. All you need to do is to pass an object as the initial value, and then we are going to access that object. So we're going to rename our array accumulator to an object accumulator this time. And we're going to access the object, and we're going to access with using the dynamic property, and we'll be accessing the current num. Each of its keys will be a number. And then we are going to do a small check over here, which will be object current num or 0. Basically, we are checking if the object current num exists in our object. If it does not exist, then make it as 0. Otherwise, if it exists, then give us the object current num, because you will get undefined when you're going to access object current num, as it will not have any value in the beginning. So if this object current number is not having any value, we're going to assign 0 to it. Otherwise, we're going to take the accessed value and we'll simply add 1 to it. And we're going to return the object. And you can see we've got a nice object over here. It's telling us that 10 is 2 times in the array, which is right. We have 2 times over here. We have 20, 1 time in the array, 30, 2 times, and 40 and 50 again 1 time in the array. That's a really nice capability of the array reduce function. Okay. We can also make array flattened. array.reduce can also flatten arrays. So suppose if we change our number array to have more arrays inside, like 110, 120, and then we have suppose 5, 4, 3. Then we have just some numbers in the first dimension. And then again, we have an array of numbers, and maybe we can nest it a bit more. Or just let's stay to one level. So we can nest this, we can actually flatten this array very easily by using the concat method. So let's rename our filter to flat. And what we need to do is just return and make sure we make this as an array, make the object accumulator as array accumulator, and we are going to return array.concat current num, or basically current value, because we're not sure in this case if it will be a number or will it be an array. And we can see we have got the flattened array. Again, that's a really nice thing. And the last thing which I'll explain, which will be really useful for the reduce function, is that you can do piping with the array.reduce. What do I mean by piping? Piping means that you can chain set of functions together for a certain input or certain value. So suppose if we had to do some calculation over here, and we have a pipeline over here. This pipeline will be empty. Let's define some really basic functions like add. This is going to take an input, or this will basically take a value. Arrow function, value plus 1. Real easy. We copy that. We can make one for half. We can make one for double. So value multiply by 2. Value divide by 2. And now we have a set of functions. We can add that to our pipeline, which is basically an array of functions in simple terms. So we have now 3 of these functions in the pipeline, and we're going to this time loop over the pipeline. So pipeline.reduce will have the initial value set to suppose some input, like we had some input. So we can keep an input value as like 30. And suppose our initial value is 30 over here, which is the input. We can place the input variable here. And what we can do is, for each of the functions and the current value, so function will pass to the function a current value. Okay, let's move that pipeline over here. We cannot access it for initialization. All right. So, okay, make sure this is the other way. This will be the calculation, and this current value will be the function, or the current callback function we're accessing. Okay. This will be our calculation. And we can see we're getting 31 exactly. Now let me explain it one more time easily. Basically, what we're doing is that we're looping over the pipeline array, and we are first of all doing the addition function on our calculation, which is basically this input, that's our current value. And then we're halving it, and then we're doubling it. The nice thing about this is that we can remove some of this from the pipeline. Suppose we can just do the addition, and we do not need to touch the calculation at all, but our value will continuously change. Suppose if we wanted to double, and then we wanted to double again, and then we wanted to add. So we're changing the value, and we just need to change the functions in the pipeline, and the reduce will stay the same. It's a really fancy and a nice way of doing multiple or chaining multiple functions together when you're doing lots of complex stuff. The last thing which I would like to say is that you can use reduceRight. Basically, what it does is that if you want to access the array in a reverse manner, so suppose if I want to access, first of all, add, double, and then double, I can just write reduceRight, and then it will access it in the reverse manner. which gives us 124 because it's first of all adding and then it's doubling twice. Now this can work with any of the previous examples which I had discussed. So both reduce and reduce.write are exactly same, and you can use it to apply to many scenarios in JavaScript. Hope you had enjoyed this video. Leave a like and subscribe, and I'll see you in the next one.